A student drives a moped along a straight road as described by the velocity time graph. Sketch the position, time graph, and acceleration time graph. Finally, find the acceleration and the position of the student at 6 seconds. The first thing we're going to do here is to segment these three graphs, namely segment 1, segment 2, and segment 3. And for the sake of simplicity, we use this time axis as the x and this velocity axis as the y. Now we're going to find the points that are important to us so that we can find or define these three segments. This one is the origin where the student started. This one is 0.3, 8. This one is 5, 8 because this is a horizontal line, which means the velocity is constant. And here for segment 3, this is up to here, which is 9, negative 8 and 7, 0. Now when we're going to define these points and find the segment, or the equation of the segment, using the 2-point form, we can find that the velocity of this first is just y is equal to 8 thirds x. And here we have just a constant, so that's y is equal to 8. And the third line is y is equal to negative 4 x plus 28. Since its y-intercept is somewhere here, 28. And then, for the acceleration graphs, all we have to do is find the derivatives of these three defined lines. Here, using the constant multiple rule of derivatives, you get y is equal to simply 8 thirds. Here, since this is just a constant, you can get y is equal to 0. And for here, this is just a constant again, and this one is a constant multiple, which means we yield negative 4. Graphing these three segments for the first 3 seconds, you get 8 over 3, which is around 2.6 or 2.7, so here. For y is equal to 0, for the 3 to 5 seconds, that's here. And for the remaining time, from 5 to 9 seconds, you get y is equal to negative 4, around here. Negative 4. There. Now, to find the displacements during this time, during these periods, we simply get the integrals since position is just the integral or the first integral of velocity. And that's why on the acceleration we use derivatives, because the first derivative of velocity is acceleration. Here, we get the integral of the velocity, which is 8 x squared over 3 times 2 is 6, or simply 4 thirds x squared. And this one is for the first 3 seconds. Y is equal to 8, just becomes y is equal to 8x. And if this is at 3 seconds, you get 9 divided by 3 is 3 times 4 is 12, plus 12, minus 12. Since we're looking for c here, 8x minus 12, which is simply inputting 3 here and then plus c. So that's 4 times 9 over 3, and then we yield c is equal to negative 12. Finally, for the third line, since we have negative 4x plus 28, our integral equation would be y is equal to negative 4x squared all over 2 plus 28x plus c. This can be reduced to y is equal to negative 2x squared. The derivative of a constant multiple is 28x. Of 28 is 28x. And then finally adding the constant. So we can also use 5 here to find c, which is just negative 62. So that would be our constant. Y is equal to, c is equal to negative 62. Now to plot this, all we have to do is to use some points. So for 5 seconds, this one will become, so that's 28, 28 here. For 6 seconds, we just do the same thing. So 36 times negative 2 is 34. 34 for 6 seconds, that's 34. And for lastly, for 9, we get negative 2 times 9 squared plus 2 is 28. Somewhere here. 28. I think we can do one more for the inflection point. So we have here for 5 seconds and for 6 seconds over here. 36. 7, 36 here. So we have these 3 points. Okay, let's graph first this one, 4x squared all over 3. That's the number 3, 3 times 4 is 12. And we know that this is a parabola, so our graph will look something like this. This one is a linear, it's a line, it's a linear equation. When we graph, for example, 4, 3, let's start with 3, we should also yield 12. 24 minus 12 is 12. Correct, that's still here. If we plot 5, or the last point of this equation, 5 first 40 minus 12 is 8, that's here. Here, exactly here. So that's when we draw this line. And for this parabola, we have these 3 points looking like this. Yeah, looking like this. So as we can see here, our inflection point is 7, 36. 7, 36. Now for answering the question of its position and its acceleration at 6 seconds, so for the acceleration, we have here as y is equal to -4. So that's -4 meters per second squared. That means it's decelerating, which we can see that the velocity is changing and it's falling or dropping. So that's -4 meters per second at 6 seconds. For the displacement, or for the position at 6 seconds, as we've graphed a while ago, we get 4. So yeah, it's 34. Which means that the position of the student at 6 seconds is 34 meters from the origin. Thank you.